Working through the handout, number 18, starting backwards. We'll start at 18 and we'll work backwards, go as far as we can go. So these are tricky. Cosecant squared, just come down here. Cosecant squared times secant. I always take out the x's. Who cares about the x? We know it's there. This one in particular has got this is 18 is actually one of the hardest ones. I circled, as I solved them all on Thursday. These are tricky enough for me that I make sure I solve them ahead of time. The other sections, I just come in here and just do them as we go because I've done them a million times. But these are tricky. So I solved them on Thursday to make sure I wouldn't be stumbling around in front of you this morning. 18 and 13 are super tricky. So I'm starting with a super tricky one. 18 is really tricky. If you look at the answers, they're all, notice, adding, subtracting. Do you see that? How are we going to go? The real trick on this one is how are we going to go from multiplying a couple of things, to adding, subtracting? That's weird. How do we do that? Well, notice first off what I could do with cosecant squared. What could I do with cosecant squared? That's 1 over what? That's upside down of sine, right? And what is secant upside down of? Cosine. Good so far? That's nothing amazing. It's not super tricky. That's pretty natural. We'll do that kind of thing a lot. Okay, so putting that together, that's 1 over sine squared cosine. I just multiplied those together. 1 times 1, sine squared times cosine. Good? So far. Trying to make it look like one of those four. And on the test, there'll also be a none of the above option. Okay. Now, here's the really tricky step. I mean, this is just not... honestly, I didn't think of it. I had to work backwards to find it. But anyway, let me just show you. Here's the tricky step. How am I going to go from things multiplied to things added and subtracted? Well, you want to have available the Pythagorean identities. I wrote those up last time, right? Sine squared plus cosine squared equals 1. Remember that one? And tangent squared, 1 plus tangent, either way, doesn't matter. 1 plus tangent squared is secant squared, and 1 plus cotangent squared is cosecant squared. You want to, excuse me, when we get to exam number 3 a week from today, you'll have those right there on your 3x5 card. You'll be looking them over thinking, which one of those am I going to use? Well, here's the trick. I can replace this 1 up here. 1 is equal to, identical to, that's why these are called identities. They're equal, they're identical value. 1 is identical value to sine squared plus cosine squared. Do you see that? That's a pretty tricky step. This 1, you replace it with sine squared plus cosine squared. We'll never do that again. That was pretty tricky. That'll lead us where we need to go. Good so far? Now, remember when you have, like what if I had 3 plus 5 over 9? I could separate that. I could go 3/9 plus 5/9, couldn't I? With me, just think about fractions, like what you know about fractions. If you had, sorry, that's kind of scribbly here. Let me make that a little nicer. What if I had 3 plus 2 over 7. I could make it 3/7 plus 2/7, couldn't I? You could separate them, right? Well, that's what I'm going to do here. I have 2 things over 1 denominator. That you should look at that as one term. They're multiplied together. They're, pluses and minuses are separators. So there's 2 separate terms on the top. On the bottom, that's one term. Why? Because there's no plus or minus between the sine squared and the cosine on the bottom. They're times, which means they're 1. They're one term, we call it. So what does that mean? That means I can separate that. Sine squared over sine squared cosine plus cosine squared over sine squared cosine. Does everybody see that? like that. Good so far? So that's just like doing this up here. It's just separating. Maybe if I had like a 6 times 7 on the bottom, whatever. Same thing. I would separate both the 3 and the 2 over 6 times 7, 6 times 7. Get the idea? It's just common denominator, huh? It's just, hey, right, you can put these back together now. I'm not going to. That would take me back where I was. But, right, it's just the opposite of common denominator. Right? Normally we combine over a common. I separate it over a common denominator. Good? Now the trick on this whole thing is there's not just one way to do these things. They're creative. This is going to work there. See what happens. These cancel, don't they? Mm-hmm. So that's 1 over cosine. Here, what happens on the other fraction? This cosine cancels one of those. Right? Because that's 2 cosines on the top, cosine squared. This cancels that. You leave cosine to the first. Over sine squared. Excuse me. Is that good to there? Does everybody see what I just did? I just canceled these sine squared, so it's 1 over cosine. Here I canceled one of the cosines on the top with the 1 cosine on the bottom, leaving an extra cosine on the top and sine squared on the bottom. Okay? Now, what is 1 over cosine? Those you really need to know cold at this point. You need to know the upside downs. You can write them on your 3x5 card, of course, but it'll really help you because that's the trick. You'll be wanting to recognize, quick recognition. You really want to have them in your mind. 1 over cosine is which one? Secant. You really want to start just knowing that cold. Secant. And then you look here and you go, You know what I could do with that? This guy, I could break. And what I'm doing is I'm looking up here going, oh, look. Secant plus cosecant, maybe. Secant plus cosecant cotan. Even more, maybe. How is this maybe cosecant cotan? Right? Because if I can show that this cosine over sine squared is really cosecant cotan, I'm there, and the answer is B. I have a strong hunch at this point it's B.
You would break it up.
Break it up, yeah. See that sine squared in the bottom? That's cosine over 1 times, cosine over sine times 1 over sine, or vice versa, it doesn't matter. There's 2 sides, 1 cosine on the top. Does everybody see what I did there? Right? Because cosine times 1 would be cosine, sine times sine would be sine squared, wouldn't it? You see that? And what is cosine over sine? Cotangent. What is 1 over sine? Cosecant. So it is secant, and the order doesn't matter. Secant plus cotan cosecant, it is B. That was pretty true. That's like one of the hardest ones. That one in number 13. We got there. We showed that it's a different way to say that same thing. Pretty tricky. Question?
You did the fractions like 1 over cosine was because secant was alone, right? It's not squared at the top.
Where you at?
So
here?
The very top. So you use the fractions because secant isn't squared.
Cosecant is squared, so that's 1 over sine squared. Secant is not squared, so it's 1 over regular cosine.
So that's what I mean. So with the secant, because it's not squared, is that why you did the fractions? Because otherwise,
no, that's just
that cosecant, and I would have done the cotangent squared plus 1.
Oh, yeah. See, I have no answer for you. I mean, you're right. I mean, sometimes when I say I have no answer, I mean you're right. Sometimes you would do that. Sometimes cosecant squared replacing with 1 plus cotan squared would be a super good idea. You know what? I'm thinking that your idea might be a better idea. I can't tell exactly. That might be easier, you know. That might be a lot easier. Oh, yeah, it is. You're totally right. Destiny, I like your plan better than mine. Let's redo it. I mean, what I did was okay, but that was weird. You're right. Let's do Destiny's plan. I like it. Cosecant squared. Cosecant. Yes, there's not one way on this, and we're seeing that right now. Yeah, I like Destiny's plan. She looked over here and said, look, Mr. Train, you wrote the 3 Pythagorean things, right? So here, I'm trying to go fast here. Sine squared plus cosine squared is 1. 1 plus tangent squared is secant squared, and 1 plus cotan squared is, is cosecant squared. Yeah, I like Destiny's plan better. I think it's going to work way better. Cosecant squared is identical to, so using these three identical, 1 plus cotan squared, right? So just take that. Yeah, I'm doing all that extra fancy stuff. Your way's better. Like that, right? Everybody see what I did there? I replaced cosecant squared with 1 plus cotan squared like Destiny said. That's right. Right, those are identical. Good. Okay. Why is that a good plan to do? A better plan? Because that's like what these all sort of look like they are, huh? We already got the plus sign in there. Now let's distribute that. 1 times secant plus cotan squared times secant. So I'm just redoing this a faster way. Our answer was right. It is B, but here's a better way. Good to there? I just distributed that secant. Anything outside parentheses multiplies the things in the parentheses, right? So already we have a secant alone with a plus. So we're thinking it's either B or D, right? Secant plus. Now, what can we do here? Well, cotan squared secant. Is that the same as one of those other guys? What I would do when you have a bunch of stuff like mixed up together, like cotan squared secant all multiplied together, I'd break it into sines and cosines. So what is cotangent? It's cosine squared over sine squared, and secant is 1 over cosine. Good so far? Right? Cotangent is cosine over sine, so I put cosine squared over sine squared. Secant is 1 over cosine. Everybody see that? And then, this is secant plus. Now, this cosine cancels one of these. Cosine over sine squared. This is right where we were a minute ago, huh? A little better than my other plan. Good to there? Everybody see that? This cosine down, cross-canceled, right? Cosine canceled one of the cosines on the top. Good to there. And that is, remember what you do with this guy? You make it cosine over sine times 1 over sine. You separate them back out. Why? Because I'm trying to match that. And that's it. It's cotan cosecant B it is. Everybody seeing that? We're done. It's a little better. Thanks, Destiny. Good. A little easier way to go. So there's number 18. I better move on. So y'all got that down? Let's keep going backwards. We're easy ones. Let me show you. 1 minus sine over cosine. Okay. What should we do with that one? 1 minus sine over cosine. In fact, let me just go to a fresh screen. I'm just going to write it here. 17. 1 minus sine over cosine. Okay, well, I would separate those over a common denominator. I would make it 1 over cosine, minus sine over cosine. See what I did there? Just separate them. Like that, just separate them. Like good, that's just common denominator separation. On that. Austin, you good?
Yeah.
Okay, and then what is 1 over cosine? This one you want to know cold. 1 over cosine? Secant. And sine over cosine? Tangent. Is that there? Is that one of our answers? I'm hoping it is. Secant minus tangent. Yep, C. Done. So see, that's not too bad, right? That's option C. We're done. So just separate them and do that. That's more of a normal one. 18 was super hard. Number 1 was super hard. We did like 2 of the hard, and then 13. 1, 13, and 18 are the 3 hardest. So you've done 2 of the hardest already. They're not all this bad. Let's go on to number 18. Or 16, working backwards. Go backwards to number 16. So that one says cotan squared of 2x plus cosine squared of 2x plus sine squared of 2x. Okay, well, don't worry about the 2x. I don't know why they're putting 2x in everything. but whatever. We'll just leave it. It doesn't have anything to do with us. So, any ideas as you look at this thing? Specifically, let me, I hope your eye goes right there. What do you think about that? What is that? 1. Remember the Pythagorean, the 3 identities I wrote for you? And I said sine squared of theta plus cosine squared of theta is 1. You want to know that one cold. You want to just recognize that. Somebody wakes you up in the middle of the night. Sine squared plus cosine squared, 1. You just want to know it right away. This is going to come up a ton all the time. Sine squared plus cosine squared is 1. Now, I wonder if that 2x is bugging you. Let me help with that. If you're looking at that and you go, yeah, I know that formula, but what about the 2x? Does that change it? Is it double? Is it 2 then? Or what is it? No, it's still 1. Let me say a word about reading math and science formulas. Whenever they give a theta or an x or whatever, that means it's just a placeholder, doesn't it? So that theta, for clarity, I think it would have been more clear in the math science world if they would have just put blanks. That's what that's really saying. It's saying if you have the sine squared of anything plus the cosine squared of that same thing, it's going to be 1. In other words, you could say sine squared of 3wm plus cosine squared of 3wm. Whatever. If they're the same, it's going to be 1. That's what that formula is saying. Do you see how that works in math and science? Whenever they write a formula and they have, originally I put a theta and a theta. Whenever they put the same letter in 2 spots, they mean that can be anything as long as it's the same thing. That's what that means. So don't be thrown off by the fact that but now if one of those was a 2x and the other was a regular x, yeah, then we'd be in trouble. We couldn't use this theorem. This theorem says if you have sine squared of something plus cosine squared of that same thing, whatever it is, then it'll just be 1. That's what that's saying. So yeah, this is all just 1. Okay, so now we get this. Okay, any ideas now? What do you think, Destiny? Cotangent squared plus 1?
I was busy writing this down.
Yeah, so that's the other one. That is, what is it? 1. So there's remember the other 2 Pythagoreans. 1 plus tangent squared is secant squared. It's not that one, is it? It's 1 plus cotan squared is cotangent. So did I write cost? Making stuff up here. All right. So see, that's 1 plus, the order doesn't matter. Cotan squared plus 1, 1 plus whatever, and the 2x doesn't matter. That's just any old angle theta. I don't even write them in. Is cosecant squared, isn't it? 1 plus cotan squared is, because you want to have those 3 Pythagoreans there. So that's cosecant squared of the same angle, 2x. That's hopefully on our list. Yep, there it is, B. B, and we're done. So scribbly B there. Good. So that one's not too terribly bad. We just used the Pythagorean identity twice. 2 different identities. All right, let's keep going. So number 15 says, we'll do maybe one more here. Cosecant plus 1. I'm just cutting out the x's. Who cares? Cosecant minus 1 over cotan squared. Okay. That one's just crying out to be multiplied on the top. You want to FOIL out that top. 2 parentheses, FOIL them. So let's do that. Boom, boom. What are we going to get? Cosecant squared minus cosecant. He's done. Boom, boom. Plus cosecant minus 1 over cotan squared. Everybody good so far? I just FOILed out that top. Right? First to both, second to both. And then these 2 in the middle cancel, right? Cosecant squared minus 1 over cotan squared, like that. See what happened there? How we doing? Any ideas? Think about these Pythagorean identities. We just use these all the time. So sine squared plus cosine squared is 1. 1 plus tangent squared is secant squared. And 1 plus cotan squared is cosecant squared. Let me direct your eyes. Doesn't this tell you to do something with that? What could you do there? Do you see what to do exactly, though?
You kind of subtract the 1. Okay, that way.
Subtract 1 from this guy? Yeah, exactly. I like how you're thinking. That's right. Esmeralda, right? Yeah, really good thinking. Boom, and that would be cotan squared is cosecant squared minus 1. So just take the identity, make it look like that. See how Esmeralda's thinking? She's thinking right. She's thinking, I don't want cosecant squared, I want cosecant squared minus 1. So just subtract 1, then I've got cosecant squared minus 1, and that's equal to identical in value to cotan squared minus 1. So that means this is the same as that, so I could put this in right there. So that becomes cotan squared. What's the bottom? Being cotan squared all along. 1, done. One of the answers is 1. C. See that move we made there? Good little move. So you see, we saw cosecant squared minus 1. We took the Pythagorean and subtracted 1. And then we knew we could replace that top with just cotan squared. And then it was 1. All right.